experiments, okay, committing an error across all experiments, actually explodes up to about 14%. Okay, so what we can actually develop here now is we can develop a generic formula. Okay, so we can develop a generic formula. You can actually see, I believe, let's just say here, so let's say our generic formula. I'll just get another piece of paper here so that the light isn't shining up too much. Let's just get a bit more paper. Where am I gone to here? Brilliant. Okay, so let me just put this here. So the probability, a generic formula, okay, associated with the probability, okay, of committing a type 1 error, okay, when we undertake independent samples tests, as opposed to an ANOVA, okay, is, well, the probability of a type 1 error, okay. Let me just cross this over here, fold this over, right. So the probability of a type 1 error, is equal to, it's equal to 1 minus the actual alpha that was fixed across the experiments, okay, raised to the power of the number of groups. Now the number of groups that we have, we've calculated, okay, well, raised to the power of the number of independent samples t-tests that we could undertake. Yeah. Now, the number of independent samples t-tests that we could undertake depends on the number of groups, okay, that we have in total associated with our ANOVA, and it can be calculated by NCR. So actually, the generic formula is 1 minus alpha raised to the power of NCR. Okay. So we know when there are well, let's say when there's three groups, okay, the probability of a t, let's say, I error, okay, is equal to 1 minus 0.05 raised to the power of 3, okay, because there was 3 groups, but there was 3 ways to select select 2 things, and we know that's equal to 0.14. What about when we have 4 groups? Well, when we have 4 groups in our ANOVA, the probability of committing a TI error, a type 1 error, okay, is equal to 1 minus 0.05. Now we've got 4 groups. So how many ways can we select 2 things from the 4 groups? In other words, well, how many ways, we've got 4 groups, how many ways can we select 2 things from the 4 groups? And the answer to this is actually there's 6 ways to do that, okay? So we go 4, second function, NCR2, 6 ways to do it. So this becomes 6, which now gives us a probability of 1 minus 0.95 raised to the power of 6, which is, oh my god, it's around 26%. Okay. What about when we have 5 groups, which isn't anything unusual? The probability of committing a type 1 error, okay, now becomes 1 minus 0.05 raised to the power of, well, we've got 5 groups. How many ways can we select 2 things from 5? How many independent samples t-tests could we do? Well, let's see. So we have 5, second function, NCR2, gives us just 10 ways to do that. So there'll be 10 independent samples t-tests, which gives us this, in this case, 1 minus 0.95 raised to the power of 10. So 1 minus 0.95 raised to the power of 10 gives us a value of about 40, 0.40%. You have a 40% likelihood. And when you see, look, when we go to 6 groups, okay, the probability of committing a TI error, okay, type 1 error, is, well, it's 1 minus alpha, which is 0.05 if it's fixed across all the experiments, raised to the power of, well, we've got 6 groups. How many ways can we select 2 things from 6? Yeah, so it's 6 NCR 2 gives us, there's 15 ways to do that, okay? So raised to the power of 15, which now gives us, that's 1 minus 0.95 raised to the power of 15, gives us a value of 54%, approximately 0.54, okay? So the idea of doing the ANOVA, okay, of doing the ANOVA is to try to find out whether there is within there somewhere whether there's a difference. Okay, and the alpha rate is fixed at 5%. Okay? It'll tell us that there is a difference in there. It won't tell us where it is, but it'll tell us that there is a difference. Yeah. Now, if we do independent samples t-tests, and the more groups we have, the error rate actually explodes. If that makes sense, that's the word that's commonly used. The error rate associated across the whole set of experiments. There was 3, there was 6, there was 10, there was 15. Independent samples t-test explodes. And don't forget, we're just trying to find out whether there's a difference. So actually, in the 6-group scenario, you'd actually be better off flipping a coin. Don't do any of your 15 experiments, just flip a coin, and the coin will give you a better odds of actually saying whether there's a difference or not a difference, if that makes sense. Okay? So guys, hopefully this video, which was just a quick video, although I'll probably break it up into sections here, a quick video exploring why we undertake analysis of variance as opposed to separate independent samples t-tests. And what I've tried to present here is that separate independent samples t-tests, the experiment-wide error explodes as compared in contrast to analysis of variance where the error rate is actually fixed for the whole experiment at 5%. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And many thanks for watching this video. Okay, bye bye.